Alright, so let's see this problem now. Given an integer array nums and an integer target, we need to return the indices of two numbers from the array such that they add up to the given target. And we are guaranteed that exactly one valid pair exists for this, and also we can't reuse the same element twice. So the order of the returned indices doesn't matter over here, but they must correspond to the position of the two numbers in the original array, right? So for example, if the input array is this and the target is equal to 9, the output should be 0, 1. Because if you see, nums of 0 plus nums of 1 will be equal to 2 plus 7, which is equal to 9, right? Now a brute force way would test all the pairs one by one, which will be essentially order of n square time complexity. But we need to solve this in linear time, right? That is in order of n time. So maybe let's see how to do that. So the core idea over here is that while scanning the entire array from the left to the right, every number, if you see, is looking for its partner complement, right? With which it will add up to the given target. And so this complement will be given by target minus the current number. Now, if we have already seen that complement earlier, then we have found the answer immediately, right? And we can return. So that means we need to essentially remember each number that we have already seen. And so for this, we will just maintain a hash map with number as the key and its corresponding index as its value, right? So at each index I, what we will do is we will compute the complement first of all at the current number, which will be given by target minus the current number. And now we will see if this complement already exists in the map. If it does, we instantly return index of complement from the hash map, comma the current index, right, which is I. And that will be our output. Otherwise, we will simply store the current number with its corresponding index in the map and move on. Now this, if you see, is just a single pass over the array, and each lookup or insert in the map is going to be order of 1 time on an average, right? So that gives us order of n time and order of n space complexity for this solution. And why order of n space complexity? Because we are using an extra hash map over here. So let's actually maybe walk through this with our example. This is the input array nums and the value of target is 9. So initially the map is completely empty because we haven't processed anything yet, right? Now we are at index 0. The current number is 2. The complement we need to find is 9 minus 2, that is equal to 7. So now we check, is 7 already in the hash map? And no, it is not, because the map is completely empty right now. So we simply store 2 with its corresponding index 0 into the hash map, and now the map looks like this. Now we move to index 1. The current number is 7 over here. So the complement we need is 9 minus 7, which is equal to 2. Now is 2 in the hash map? Yes, it is. And it was stored at index 0, right? So that means we have found our pair now, and we can simply return 0, 1 immediately over here. And since the problem guarantees exactly one solution, we actually don't need to continue any further, and we are done at this particular point. So that's the entire solution. Now maybe let's go through the code for this. So first of all, we define a function TwoSum that actually takes in the array nums and the integer target, right? And it will return a list of two indices. Now we create an empty dictionary called num_map, and this will store the numbers we have seen so far as the keys and their corresponding indices as the values. Then we start a loop over the array using enumerate, right? And this way for each element we get both its index I and its corresponding value num. Now we calculate the complement, which is simply target minus num, and this is the number we are hoping to find in the hash map. So we simply check if the complement is already present in the num_map, and if it is, then we know we have already seen the other half of the pair. So if the complement exists, we immediately return the pair of indices, that is the index where the complement was stored and the current index, right, which is I, and that gives us the answer. And if the complement was not in the map, then we store the current number with its index I into the map, and this prepares us for the future iterations. And that's it. Since the problem guarantees there is always exactly one valid solution, the function will always return inside the loop, right? So essentially by asking each number for its missing partner and remembering everything we have seen, we turn a quadratic search into a linear one. So that's actually the power of this one-pass HashMap solution. And since we are just traversing the array once in a single pass, the time complexity of this solution will be order of n. And since we are using an HashMap over here to remember all the elements that we have seen so far, the space complexity will also be order of n, right? So I hope this is clear, and now I will see you in the next problem. Happy coding!